Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All righty, so today we're going to take a look at section 7.4, which is adding and subtracting with unlike denominator.
Mr. Mayo, I had some questions on the homework.
Okay, what do you got?
So, sorry, 1 second. Okay, so one of them was 33. It was the building the rational expression with the given denominator. And it's y plus 7 over y squared plus 16y plus 63. And then the second part of that, the denominator part is 8y, y minus 9, y minus 7.
Like that?
Yeah.
Okay, something's not right. The denominator is y squared plus 16y plus 63, or is it minus 16y plus 63?
Hold on. Okay, so it should be y plus 7, y squared, minus 16.
Okay.
Minus 16, yeah, and then the rest is right.
All right, so if we take this original rational expression, can you go ahead and mute your phone there because the noise from the other room or whatever is coming? Thank you. Okay, so the rational expression, we could factor and get y plus 7 over y minus 9, y minus 7, okay? And then we want the new denominator to look like this. So what's missing over here? 8y. So the new numerator is going to be 8y squared plus 56y, and then that's going to be our new complete fraction. Okay, you can go ahead and unmute there. Is that you okay with that?
Okay, yeah, that makes sense. I was multiplying when you did the 8y on the numerator and denominator, I did y minus 9. I don't know why I did that. I was confusing myself, but that makes sense.
Do you have any other questions?
Yeah, and then it was 34. It's 17 minus h over h squared minus 25. And then the second part of that is 2h plus 5, h minus 5.
So this is we're building.
So the denominator part is 2h plus 5, h minus 5.
Like that with the 2 outside?
Yes.
Okay, so the original difference of 2 squares, h plus 5, h minus 5. So what we're missing is a 2 right there. So we're going to multiply the numerator by 2. We're going to get 34 minus 2h. Like that.
Okay, that makes sense. Thank you.
Any others?
No, that was it for now.
All right, anybody else? Any other questions before we go on? Okay, then we're going to go on to section 7.4. And let's say we've got the following. Y over 4 plus 3y over 5. So we want to add two fractions that have different denominators. So the first thing we need to do is to figure out what the least common denominator is. Well, the least common denominator of 4 and 5 would be 4 times 5 or 20. Is everybody okay with where I got that? Any questions there? All right. So my next step is to build each of the original fractions so that it has the new common denominator. So y over 4, if I multiply the denominator by 5, I get 20. So multiplying the numerator by the same 5, I get 5y over 20. So y divided by 4 becomes 5y divided by 20. The second fraction, to get 5 to equal 20, I have to multiply the denominator by 4, which means I also have to multiply the numerator by 4. 3y times 4 is 12y. So 3y over 5 gets built up to 12y divided by 20. All right. So I determined the least common denominator. I built each of the original fractions to new fractions with the same denominator. Now I can go back and add the numerators over the common denominator. Finally, can I reduce this? Well, there's nothing I can do to reduce 17y over 20. So that's the final answer. Any questions about this particular problem? Okay, let's take a look at another one. This says 6 over n squared minus 2 over n. So the first thing we need to do is find the least common denominator. Well, if we were doing the factoring of n squared, it would be n times n, and the factors of n would just be n. The highest power of n is n squared, so the least common denominator is n squared. So we need to get to here. Well, if it ain't broke, don't fix it. The first fraction, 6 over n squared, stays as 6 over n squared. The second fraction, to get from n to n squared, I need to multiply by n, which means I also need to multiply the numerator by n. So now the new numerator becomes 2n. So 6 over n squared stays as it was, minus 2 over n becomes minus 2n over n squared. Now I have two fractions that I'm subtracting. They have the common denominator. So I'm going to subtract the numerators over the common denominator. Now, I can factor a 2 out of the numerator. However, doing that doesn't produce common factors in the numerator and the denominator, so it doesn't get me anywhere. I just had to check it. So here is my final answer. Any questions there? All righty. Let's see here. I've got 7 divided by 8b squared minus 5 divided by 6b cubed. 8b squared is 2 times 2 times 2 times b squared, or 2 cubed times b squared. 6b cubed is 2 times 3 times b cubed. So my least common denominator would be 2 cubed times 3 times b cubed. Remember, the least common denominator is the product of the highest power of each different prime factor. Okay, and this would be equal to what? 8 times 3, 24b cubed. Okay, so I need to get to here. So what do I need to do to 8b squared to turn it into 24b cubed? I need 3b, which means the numerator needs to be 3b times 7, which is 21b. So 7 over 8b squared becomes 21b over 24b cubed. Any questions there? All right. I need to change 6b cubed into 24b cubed. So I need to multiply the denominator by 4 and the numerator by 4. So my new numerator is 20. So 5 over 6b cubed becomes 20 over 24b cubed. So now I'm subtracting two fractions with the same common denominator. So I'm going to subtract the numerators, 21b minus 20 over 24b cubed. There's nothing I can do to the numerator. I can't factor anything out of it to see if it will reduce with the denominator. So that's my final answer. All righty. Any questions there? Okay. 5 divided by p squared minus 9 plus 2 divided by 3p plus 9. To find the least common denominator, I'm going to factor each of the current denominators. P squared minus 9, let's see, I would have p plus 3, p minus 3. 3p plus 9, I'd factor out a 3 and have a p plus 3 left over. Okay? So my least common denominator would be 3 times p plus 3 times p minus 3. Now, unlike in the last problem, this one, I'm going to leave my LCD all factored out. And I'll explain why in a minute. This makes it obvious what's missing. To get from here to here, I need what in the denominator? I need a 3, which means I need a 3 in the numerator, and my new numerator becomes 3 times 5 or 15. Second fraction, what am I missing? P minus 3. So I need to multiply the numerator by p minus 3. So my new numerator becomes 2p minus 6. Any questions about that? So I factored each denominator, determined the least common denominator, took each original fraction, built it to the new fraction with the LCD. Now I'm going to add the numerators. So I have 15 plus 2p minus 6 over the LCD, which is 2p plus 9. And now I'm going to go ahead and write the LCD. There's nothing I can do to factor the numerator. So that's my final answer. The only difference would be if you wanted to multiply the denominator all out, but unless it asks you to, it shouldn't be required. So I would just go ahead and leave it like that. Any questions there? Okay. Let's see here. How about this one? 9 divided by 2c squared minus 2c minus 5 divided by 2c minus 2. So taking the first fraction and factoring the denominator, I get 9 over 2c times c minus 1. Taking out the greatest common factor, okay. Second one becomes 5 times divided by, I can factor out a 2 and get c minus 1, okay. So the LCD would be what? 2 times c minus 1. Okay. Any questions there? So the LCD is in fact the denominator of the first fraction. So I don't need to build anything there. the second fraction to get here, I need to multiply the denominator by c to get 2c times c minus 1. Consequently, multiply the numerator by c, and the new numerator becomes 5 times c. Now that I'm subtracting two fractions with the same denominator, I'm going to subtract the numerators over the common denominator. There's nothing I can do to factor the numerator to try and reduce it down. So again, that should be my final answer. Okay, let's see here. We good to go on? Okay. I have 2 divided by a squared plus 4a plus 3 plus 1 divided by a plus 3. To find the least common denominator, I'm going to factor the given denominators. So the first fraction becomes 2 over a plus 3 times a plus 1. The second fraction remains 1 over a plus 3 because I can't factor it any further. So my LCD is a plus 3 times a plus 1. So in this case, the first fraction already has the least common denominator. The second fraction, I need to multiply the numerator and the denominator by a plus 1. So now my denominator is that, and my numerator is a plus 1. Any questions yet? So now I'm adding two fractions with the same denominator. So I get 2 plus a plus 1 over the LCD, which is a plus 3 over the LCD. Now, the reason I do this is because I'm not going to be doing anything with the denominator in that step, and it just saves time. You know, you can do it, you can not do it, but in your final answer, you can't use that. You have to do the actual numbers. So now I can reduce out a plus, oops, let's try that again. I can reduce out the a plus 3s and get 1 over a plus 1. Now, again, be careful to note, it's not a plus 1, it's 1 over a plus 1. These don't cancel, they reduce down to 1 over 1, so there's still a 1 in the numerator. All righty? Good to go on. Here comes another one. 6 divided by s squared minus 9 minus 5 divided by s squared minus s minus 6. So factoring the denominator of the first fraction, we get 6 over s plus 3 times s minus 3, the difference of two squares. The second denominator, let's see what we get here. How about s minus 3 and s plus 2? That would give us a minus 6 at the end and a minus 1 in the middle, minus 1s. Okay. So our LCD is s plus 2, s plus 3, s minus 3, one of each. Okay. Any questions there? I'll take that as a no. Okay. So now we need to get to here. And here. So the first fraction is missing a factor of s plus 2. So my new numerator is 6s plus 12. It's a good thing I can write outside of the whiteboard there. The second fraction, I'm missing an s plus 3. So my new numerator is 5s plus 15. Okay. So now I'm going to subtract two fractions with the same common denominator, but I need to be careful. This is that issue we talked about yesterday. I'm subtracting that entire thing. So I'm going to get 6s plus 12 minus the quantity 5s plus 15 all over the LCD, which is going to give me 6s plus 12 minus 5s minus 15 all over the LCD, which is going to give me s minus 3, combining like terms, all over the LCD, which I'm now going to write because I'm going to be using it in this step. Okay, so far so good. I'm going to come in and reduce the s minus 3's. So I end up with 1 over the quantity s plus 2 times s plus 3. So again, we've got the original two fractions. We need to get a common denominator. So we factor each denominator, determine the LCD, build each fraction to where it has the LCD. Then we can add or subtract the numerators accordingly. And then finally, if we can reduce it. And again, this step right here, where you're subtracting the entire quantity, that's the thing people tend to miss. They don't group that numerator before they subtract it. Okay. Let's see here. How about this one? 9n over m plus 4 plus n. There's no denominator written for the second term, but there is an implied 1, right? Okay. I can't factor the first fraction's denominator or the second any further. So the least common denominator is m plus 4. So this doesn't change. The second one gets multiplied by m plus 4 in the denominator and m plus 4 in the numerator. So we've got m plus 4 in the denominator and mn plus 4n in the numerator. So now we've got 9n plus mn plus 4n over the LCD, which is, let's see, 13n plus mn over m plus 4. And I can't do anything. Oh, yes, I can. I could factor an n out of the numerator and get that. However, that doesn't do anything for us. So we'll just go back here. But I always want to look and see if there's something I can factor out, then maybe I can reduce the final answer, because you just never know what they might do. Okay. Questions there? Nope, we're good. All right. How about this one? 4 over b minus 6 plus b over 6 minus b. Let's see if I can write that better. 4 over b minus 6 plus b over 6 minus b. Now, at first glance, you might look at that and say, oh, the LCD is b minus 6 times 6 minus b. Things don't have to be that bad. Consider this, okay? Let's go back to the other day when I don't think anybody was here live, at least for the first part. b minus 6 and 6 minus b, those are opposites of each other. So what I can do, I can take one of these fractions and multiply it by -1 over -1. Okay, what is that going to do? Well, my first fraction is going to stay the same. My second fraction, in the numerator, I'm going to get what? -b. In the denominator, I'm going to get -6 plus b. But -6 plus b is the same thing as b minus 6. So in fact, what I've done by multiplying the second fraction by -1 over -1, the numerator becomes the opposite of what it was. The denominator becomes the opposite of what it was. It now matches the denominator of the first fraction. So I've got 4 minus b over b minus 6. Now, why did I change this fraction instead of that one? Well, because this one had a denominator that was in standard form, b minus 6. I could have done the same thing over here instead, and then they both would have been 6 minus b, but I just liked to do it in standard form. So here's the final answer. Do you have any questions about that? Okay. Let's take a look at another one of these. A divided by 5a minus 3b minus b divided by 3b minus 5a. So again, I notice that the denominators are opposites. So I'm going to leave the first fraction alone. I'm going to multiply the second fraction by -1 over -1. So my new numerator becomes -b. My new denominator becomes -3b plus 5a. But -3b plus 5a, addition's commutative, that would become 5a minus 3b. Okay. So now I've got a minus -b over 5a minus 3b. But a minus 3b is like a plus b over 5a minus 3b. And trust me, that's a lot less work than taking all of that times all of that as your LCD. Then you create a mess that you don't want to go there. Okay. You'd be better off spending your time watching Star Trek reruns. All right. Let's see here. Let's take a look at this one. 10h divided by h minus 3 plus 7 divided by 9h. Well, let's see. H minus 3 in itself can't be factored any further. 9h would be what? 3 squared times h. Okay. My LCD is going to be h minus 3 times 9 and times h. Because again, this h is not a factor in itself. So this h is a factor. So you've got 9 and h minus 3. In case it's bothering you, we'll write it this way. It doesn't make any difference, but okay. So that's our LCD. So let's get rid of this circles. I need to multiply the first fraction by 9h over 9h, which gives me 90h squared. I need to multiply the second fraction by h minus 3 in both the numerator and the denominator. So I get 7h minus 21. So now my numerator is 90h squared plus 7h minus 21 over 9h times h minus 3. So then the question is, can I factor that numerator? Wow. Well, let's find out. I'm going to take this thing and rewrite it on the next page. 90h squared plus 7h minus 21. So this is a trinomial. It's in standard form, okay? There's no greatest common factor. It doesn't have a leading coefficient of a 1. It's not a perfect square. So I'd have to use grouping or trial and check. Well, you know what? That just seems like an awful lot of work. So I'm going to give you an alternative method to deal with this. Let's go back here. If this fraction is going to reduce, that means that the numerator and the denominator have to share a common factor. Let me give you an arithmetic example. Let's say I've got 25 over 18, okay? Well, 25 is 5 times 5. Now, I could do the prime factorization of 18, or I could say, well, you know what? 5 is not a factor of 18, right? So even if I go to all this trouble, it's not going to reduce because they don't share common factors. So I'm looking for common factors. Okay, let's see if you're still with me here. So what I'm saying is, if this thing is going to reduce, then the numerator has to contain either a 3 or a 9 as a greatest common factor, or an h, or an h minus 3 as a factor. Okay, well, so this is 3 times 3 times not h times n minus, or excuse me, h minus 3. 3 doesn't go into the 90h squared plus 7h minus 21. It doesn't go in evenly. You can't factor 3 out. You can't factor an h out of any of them either. So the question is, can you factor out an h minus 3? In other words, can I write this as that? Are you following what I'm saying? Okay. Well, for that to be true, I'd have to have what? 90h and a plus 7 in order to get the first and the last terms. But that would give me minus 270h plus 7. That's not going to work. So my conclusion is that's my final answer. Okay. Now, why did I go to all that trouble? Because I was too lazy to factor that whole mess. And looking at it, it's like, well, if it doesn't share a common factor, it's not going to reduce. Does that make sense? Okay, so that's kind of a shortcut. Let's see here. How are we doing? Let's do this one. 21y divided by 12 minus 7y divided by 6. Can you see that the LCD is 12? You okay with that, or do you want me to go through the steps? Okay, so this is going to be 21y over 12 minus, I've got to multiply the 6 by 2, so the 7y by 2 becomes 14y. So now I've got 21y minus 14y over 12, which is 7y over 12, and nothing reduces any further. Okay, all right. Let's take a look at what the authors call lookalikes. So here's problem A. It says 5 over 2x plus 4x over 15. And then over here we'll have B, which is 5 over 2x times 4x over 15. So for the first problem, we're adding terms, so we need to have a common denominator. The LCD would be 30x. Are we okay with that? So this becomes 30x, 30x. I need to multiply this by 15 over 15, so that's 75. and this by 2x over 2x, and that's 8x squared. So adding, I get 8x squared plus 75 over 30x. And I can't reduce that in. So there's my answer to the first problem. Okay. Now, the second one, multiplying, I don't need a common denominator. 5 over 15 is 1 over 3. 4 over 2 is 2 over 1. X over x is 1 over 1. And I get 2/3. So don't forget, just like with arithmetic, if you're adding or subtracting fractions, you've got to have the same denominator before you can do that. If you're multiplying, you don't need a common denominator. If you're dividing fractions, you change it to multiplication of the reciprocal, and then you still don't need a common denominator. Okay, finding one is a waste of time and energy. All right. Okay, so for tonight, section 7.4. I'll be back at 1:15 with an office hour if you have any questions. And I'm going to go ahead and stop the recording.